Hi, everyone. Welcome. Everyone's such a good crowd. I walk up here and it went quiet. Welcome. Good evening. I'm Kristen Uhlenbrock. I am the Executive Director of the Institute for Science and Policy. If I've not had the pleasure of meeting you, please come say hi. So thankful to see such a good crowd here in person tonight, and also welcoming our online audience as well, making sure we've got that all set up. Looks like we do. So this is our event, Trust in Science. Tonight, we're talking about the science of trust. This is kicking off a series for us called Trust in Science. And actually, we'll offer, as I'm looking at this slide up here, there's something missing from this slide. I wanted to say there's a typo, but there's actually just something missing. What did I hear there? Faces are missing, okay. What I think is missing is a question mark after trust in science. Right? This is not meant to be a declarative statement. It's meant to be an exploration of what does it mean to trust science? Why do we trust science? Why do we distrust anything? Right? So we have this statement in this series that we're kicking off. This is the first one in person, so you're welcome. But I actually think there's a lot to it, right? If you take both of these words, if you take the word trust and you take the word science, there's a lot to kind of unpack there. I was thinking about this even just a few weeks ago. I was like, what makes myself trustworthy? Like, what are those elements that someone would use to trust me? Reliability, credibility, authenticity, these sort of things, right? And then we started applying that to society, to institutions, to people, right? It's a really hard concept. There's a million quotes out there about trust, right? And how you break it and how hard it is to build it back. You know, trust is like a piece of paper. You've probably heard that. If you crumple it, it's really hard to kind of get that paper flat again. And then you take the second word in this, right? Science. You're like, okay, what do we mean with science? We're talking about evidence, data, facts, right? Those sort of things that exist that matter in our world. Are we talking about people, scientists? What does it mean to trust people? Science as an institution or an organization, science as a system, as a way of thinking, right? So when you start combining these ideas of trust and science, it's not some sort of declarative statement that we should just trust in science, right? It's this messy, squishy process that involves people. And it matters, right? I can't believe any of us in here don't think that it doesn't matter to think about how we can and should be building trust in science and in institutions and in processes to help inform our lives and our decisions. And yet how we go about doing that in our society is extremely critical. At times it's fractured, can feel divisive, but it's really elemental to kind of who we are as a society, perhaps as a healthy democracy, about how we think about and approach certain elements around trust in science. So that's kind of why we're kicking off this series. And there's a great way to kick it off, which is to kind of start with the neuroscience side of it, the social science side of it, hence the science of trust, and how we think about building, how trust shows up in ourselves, in our brains, and in our bodies and our behaviors. So we have an amazing speaker tonight. I'm going to stop talking and introduce him and let him come up here. And then we'll have a little bit of a Q&A with him as well. And we'll have an opportunity for you all to ask questions. And believe me, I have plenty of my own, but I want to ask your questions. So we'll give you a chance to do that, but we're going to let him say a few remarks. So I'm really excited to have Paul Zak with us tonight. He's an author, he's a scientist, he's a speaker, you'll hear that. He's an entrepreneur. His academic lab and companies, he has started to develop and deploy neuroscience technologies to solve real problems faced by real humans. He's also a professor at Claremont Graduate University in the School of Social Science, Policy, and Evaluation. He has more than 200 publications, which have been cited more than 20,000 times. He's got 2 decades of research under his belt. It's taken him from the Pentagon to Fortune 50 companies to the rainforests of Papua New Guinea, where he's got to share his ideas and his research around neuroscience, but what I like are the terms neuroeconomist, neuromanagement, and neuromarketing. So we're going to hear about some of those themes tonight. He's written a number of books, one of which we have signed and some limited number of copies on sale tonight, which is his book, The Moral Molecule, which is about oxytocin. It's a great book. It's about 10 years old, but it is extremely timely and relevant still. He has a newer book out, The Little Book of Happiness, A Scientific Approach to Better Living. So please join me in welcoming Paul Zak to the stage.
Hi, folks. Thanks for showing up. I want to talk a little about trust in the brain, trust in science. I want to give you my answer to Kristen's query without a question mark. Should you trust in science? My answer is no. Because scientists don't trust in science. There are conditions under which I think you should trust in science, and I'll talk about those. But science is a system that makes trust unnecessary. So let's talk about that. I know we have some working scientists here, but I do want to go through a little about how the sausage is being made. So the first question is, why should you trust me? So I run a very busy behavioral neuroscience lab at Claremont Graduate University. I've been publishing research for 30 years. As Kristen said, my research has been foundational for lots of other scholars. And I've also worked on the brain basis for trust in other people, trust in institutions, and I'll tell you a little about that as well. So I've had over 100 PhD students do their dissertations in my laboratory. For all of them, I have to have the same discussion I'm having here with you, which is, please do not trust in science ever. So we are trained, and I train my students to be skeptical about everything. Why? There's no perfect study, there's no perfect experiment because of lack of time, because of lack of money, because there's only certain things you are allowed to do to humans or animals. Yeah, humans complain a lot. Animals do too sometimes. So I've done, in the last 25 years, I've done 10,000 blood draws on humans and maybe 50 on animals. So yeah, humans, I've taken a lot of blood out of the system. But we do that to measure objectively what's happening in the brain neurochemically to understand the varieties of the human experience. And one of the most interesting things about that human experience is that we are anatomically quite different than every other mammal in that we are hypersensitive to social information. So that means that this thing that we're doing, a bunch of strangers coming together, totally normal for us, right? No one looks completely stressed out. A couple of people in the back look a little stressed, but anyway, most people look good. Right now, think of our closest genetic relative, chimpanzees. You could not do this with chimps. I mean, fur and blood would be flying immediately. They just can't do it. So the first thing about trust is it's totally natural for us. So of those 10,000 people, and now we have wearable technologies where we can measure effectively these neurochemicals at scale. And we've done that for over 50,000 people now. It's very natural. Our default is actually to trust. And that's why when I train graduate students, I have to train them not to trust what they read. Does that make sense? So because you'll find the errors, and the errors tell you where you should do more work, and some of those are small sample size, improper statistical methods. And also, the scientific journals are designed to do bad work. Let me tell you why. So the top science journals in the world, general science journals, people agree, yeah, Science and Nature, they're very expensive. Some people have individual subscriptions. They charge libraries, I don't know, $8,000, $9,000 probably now for a year subscription. And they have a big incentive in creating more subscriptions. Just like the New York Times or the Denver Post, I'm guessing, want you to keep reading, or online stuff, right, eyeballs. So I did some fundamental research on trust in 2005, published in Nature. Amazing. We brought in champagne to the lab. I mean, it changed the trajectory of my career. I was on the map. Wonderful. And I was at a conference, I don't know, within the next 7, 8 months, and I ran into the editor of Nature, who I'd never met because, you know, it's a big institution. And I said, hey, by the way, I'm working on the follow-up on this thing, and, you know, I think we'll send it to your journal as well. And he goes, you know, we're not really interested. Like, we want the first thing. We don't want the follow-up. We don't want the... So part of your skepticism, and my skepticism, is one thing which gets the headline, probably not correct. So again, what we publish in Nature has been replicated, and there's some conditionalities in which this holds or doesn't hold. we've extended it, and now I've done, with oxytocin and trust, I don't know, dozens of published papers in peer-reviewed journals, and there's a huge literature that's followed that, and almost everything we've done has been confirmed. Awesome. Then I trust the results. Then I trust my own results. So again, from a working scientist perspective, I never want to trust my own findings. So from the journal's perspective, they want the new thing to get eyeballs, just like YouTube or any online. So if it's been done once, could be luck. All kinds of luck in science. Let's talk a little bit about fraud. There's a little bit of fraud in science. There is this saying we say that you're only as good as your last paper. You got to do the new thing all the time, a lot of pressure. And there are people who cheat. Nowadays, when you submit a article to a scientific journal for peer review, well, we'll talk about peer review in a second, you have to submit your data. In the old days, you didn't have to. So now anyone can see it. And there are people who've made whole careers at taking other people's data and reanalyzing it, and or say using better statistical methods and finding that there are errors, and sometimes the key results are overturned. And by the way, when you get that, so as a working scientist, you also get asked to peer review other people's work. And I have gotten, replications of my own work, and you go, oh my gosh, I hope it worked, right? So far, I'm in the clear. No one's overturned anything, I've done that's important. Again, on the edges is always a little bit of difference. And so that's a good thing. I think this requirement to make sure that you share your data. So let me tell you a little story about that. So the oxytocin is this neurochemical that promotes social connection, trust, of the kind of good social behavior, generosity, charity, lots of these good behaviors, virtuous behaviors we see in humans. And that really hadn't been studied before my lab started doing this in the early 2000s. So we developed protocols to measure that. So how do I confirm that result? Lots of different studies do it lots of different ways. We used synthetic oxytocin that we can infuse to the human brain via the nose. We've done that. I've done that 700 times in various studies and haven't killed anybody, which is amazing. So yeah, so far I'm in the clear. The anti-oxytocin is another way to understand that. And the anti-oxytocin, or one of the anti-oxytocins, is testosterone. So we've done a lot of studies looking at the effect of testosterone, and we've shown that it makes men in particular, women to a lesser extent, selfish, risk-taking, over-optimistic, overconfident. You know this because you've met teenage boys, right? Half of you used to be teenage boys. So we do this study. We send it to a top journal. 6 days before it's published, another group in Switzerland publishes essentially the identical study with the opposite result. Now, what happens? So they used women, we used men. We measured baseline testosterone in blood, and after we gave them a drug or placebo, the synthetic testosterone, measure them again. So we look at what we call the parametric effects. The more testosterone you have, because it's metabolized at different rates in different people, the worse the effect the bad behavior should be. And this is sort of a bad behavior. These guys found good behavior in women given testosterone. They didn't measure before or after their testosterone levels. So what do we do? Well, we all know each other. So I email them, hey, shoot me your data, and I'll send you our data. So we analyze each other's data. I'm at a meeting some months later, and their postdoc, who's first author, we sit down and have lunch. And I say, you guys have no effect. If you twist around, stand on one foot, wiggle your toes, you can get a tiny effect. We have an enormous effect. And by the way, there's no literature showing that testosterone makes men or women more generous, which you claim, nicer, a better decision maker, less impulsive. I mean, come on, there's a giant literature. We know about this. We did it in a hopefully kind of a clever way. So their finding is anomalous. Hasn't been replicated, mine has. But we talk to each other, right? What's happening now is that all these journals are online, of course. There is a blog for every paper that is published. And so people can write about it. Now, after I've done this paper, it's a couple years of my life. I spent a lot of time working on it. I got a big lab. I got to move on. I never contribute to the blogs, except in this case. I said, okay, well, let me write down a rejoinder on why I think our approach is better than their approach. Here's the controls we used. We had better statistical methods. We had a smaller sample size, but we had more controls, whatever that means. And then a couple months later, they wrote a rejoinder. They said, you guys suck. Here's why we think our study's better. fair enough. That's great. This is good for science, right? So I wrote back on the blog and I said, well, what's best practice for this kind of study, behavioral neuroscience study? Take blood before and after, measure actually the thing that you're trying to manipulate, do these things, use this kind of statistical method, basically all the stuff we did. And I said, some other third lab should replicate this, not us. Now I have a bias, right? And you come in with a bias, right? I'm not coming into a study with no idea what's going to happen, with some exceptions. I'll tell you about that in a second. But we have a bias. We call these hypotheses. Essentially, it's a bias. I'm going to run this study because I think this thing will happen. I think if I give you testosterone, it'll have the opposite effect behaviorally as if I give you oxytocin. Awesome. Let's study that. Let's make sure we get conversion evidence. If the anti-oxytocin gives me the bad behavior and the oxytocin gets me the good behavior, I have more conversion evidence. I have more trust in these kinds of findings. Right? So when that happens, I'm building up a portfolio of findings. Does that make sense? So why should you trust science? If there's a portfolio of findings from different labs doing different techniques, studying different populations, then it's probably correct. Evolution, it's correct. There's 4 bazillion studies. It's easy with bacteria in a petri dish to see it evolve. Just change the food source. They'll evolve really rapidly. It's easy to do it. That experiment's been done 1 million times. On the edges of that, are there some differences? Absolutely, some pretty cool stuff. Naked mole rats, all kinds of weird species that were predicted before they were found. Okay, I'm cool with that. It's not my field, but I understand at the edges there are going to be some interesting issues, but down the center is correct. Is oxytocin a key neurologic signal that makes us trust other people? Yes. So our bias now as, say, consumers of science is that we're defaulting to trust, which is what humans do because we're social creatures. Hey, this scientist or the Denver Post or the New York Times said this is a cool new thing published in Nature or Science. It's got to be right. Maybe. My view is maybe. I'm going to read it and think, this is interesting, maybe. I was talking to somebody before about, maybe it was my friend Natalie, where is she? Hi. About red wine, right, having antioxidants. What do we learn from that? Yeah, it has antioxidants. You have to drink so much, you'll be on your butt every night, and you'll die from alcohol poisoning to get enough resveratrol, right? So that's a true finding, but it's not a useful finding to me. Yes, you can buy, freeze-dried resveratrol. You can take pills, whatever. Doesn't seem to have much of an effect, in my view. I'm not an expert in this area, but I'm skeptical. Interesting finding, is it useful? So I think that's maybe where we want to go with this, is if it's true and useful, then I'm something I may want to act on. I want to change the way I'm thinking, change the way I'm behaving, if this is true and useful. If it's true, think of all the longevity research in mice. Easy. Blood transfusions from young mice to old mice, they live longer, on and on and on. Do you really want to get a blood transfusion from your niece or nephew? I don't know. I think we're not quite ready for that. So I'm not saying it's not true. I'm just saying it's probably not useful for humans yet. Right? Understanding the mechanisms through which younger blood helps people live longer or mice live longer, that could be interesting. So again, in my lab, we're really interested in mechanism. This is the, correlation is not causation. The reason we do drug studies in my lab is so that we can cause a change in brain activity and see if that causes a change in behavior, right? So I'm not interested in drug use on its own, drugging people. It turned out actually you can pay people to take drugs in your lab, who knew? But we're doing that to look at these particular mechanisms that we've identified in other research and trying to manipulate that. I'm pushing on that little part of the brain to see what happens. So I want to get that causal evidence. There's a lot of areas in science where we're not going to be able to get causal evidence, or we get it too late, right? The diagnoses for dementias until very recently, last couple of weeks, were post-mortem. You have Alzheimer's disease, we only know for sure when we diagnose your brain, when we take it apart. Right, so again, there was just a brand new FDA-approved blood test now for dementias. How accurate is it? I don't know, not my area, right? But I think, like early detection of cancers are getting better and better with blood tests. And so I think of this as incremental progress. So as Kristen said, we think of trust running on a continuum. Kristen's wonderful, we just met. Well, we had a Zoom, but we just met. I don't really want to give her the keys to my house. Maybe the keys to my car if you had to do an errand, I'm cool with that, but not my house, right? Probably not. So there's degrees of trust. So I think from my view, my trust in science is low until I see enough convergent evidence and I see a mechanism of action. I actually know why this is occurring. So we see this a lot in advances in medicine where we see an effect of, say, a drug or a device. We don't really know why that's happening. Aspirin, the mechanism behind aspirin was not discovered until the 1960s, even though it was known to reduce fevers, for example. Why it did it, we didn't know. That's okay, it's still useful. I don't know why it's useful, but it's useful. So I think to trust in science, I want to know, lots of people have done it. Aspirin study. Zillions of people did it for years and years. Aspirin was discovered, I don't know, in the late 1800s. Someone here probably knows better than me. But it's been around for a long time. It comes from a tree bark. And so it's been around for a long time. Lots of people studied it. They all found, or almost all found, the same effect. And then finally someone found out the mechanism behind it. So now I'm really convinced. And then we also know that it stops things like clotting and can be used with heart attacks. Okay, all that's good. We know about the mechanism. So now we have more applications of this. So trust but verify, that's an old Russian proverb. Trust but verify. Like, oh, this is kind of interesting. I have some degree of trust. Let me talk to my friends. Let me look at experts. Let me get some opinions online. Hopefully they're informed opinions. And then think of this as almost voting. I'm going to talk to all the people I can and go, should I be having 8 glasses of red wine every night with dinner? Probably not. There's probably a downside to that. I can probably get more antioxidants in my body in some other way. But I certainly want to talk to more people. And I think that includes non-scientists, right? So all of us who've been on the planet for more than 15 years probably have pretty good intuition for things, right? We've been around. And I think that's also valuable. So I don't want to throw out the baby with the bathwater, nor do I want to go the other direction, right? There's a correlation between when kids get vaccinated and autism. There's no causal link at all. In fact, the data claimed to show that was faked and debunked. And that guy lost his medical license. It is a correlation, but it's not causal at all. Right? Autism has got other causes, not vaccines. They just happen to run when they're diagnosed when kids get their vaccines. So, but talk to your friends. So again, if you're stereotypical, I have my friends in the front row, Orange County mom who decides not to get her kids vaccinated for measles, and then they had a kid die recently of measles. Measles, 100% preventable, or 99.9% preventable. But she's so smart, because she didn't go to medical school, that she knows. So again, I want to talk to her. I think everyone should have a voice, but also I want to sort of have that degree of trust and then aggregate all that information and go, I talked to all my friends, I read some stuff in the newspaper, people I think are reasonable, and 9 out of 10 say this thing's probably true. It's probably true. So I think one of the great things about having these social brains that we have is we can draw on each other. And so trust in science, I think, is something that we can do with each other. So be kind. If people disagree with you, to me, that's awesome. I love when people disagree with me. By the way, that's the funnest thing about science, is my little simple hypothesis that if I do A, B will happen, almost always wrong. It's not A to B, it's A and then C and F and G and Z, and then I get to B. I'm like, oh, the world's so much more interesting than my tiny little brain thought about, right? And then I learned something. So I try to do the same way in the world. If I talk to someone with a different opinion than me, I will learn something. Maybe I discount them, right? Stereotypical Orange County mom. Maybe I discount her, but maybe I should listen to her. First of all, just give her the privilege of letting her do her little thing. Go, well, almost everybody in the world thinks you're wrong. You do what you're going to do. It's your kid. I can't tell you what to do, but almost everyone disagrees with you, right? So, but I think having people have their piece is fine. One more thing, and then we'll go to some Q&A. Fraud. Because you have to release your data when you publish your papers now, The amount of fraud is moderate to low, but almost everybody gets caught. It's like fraud, financial fraud. Someone's going to find out because people have a stake in the game, right? So again, there are great data scientists who just make a practice of checking other people's work. Awesome, love these guys. There's been a big replication crisis, particularly in psychology, but in a couple other fields. Why in psychology? We probably have some psychologists here. But I'm sorry, if you think about your experiment, you don't need to deceive anybody. So psychologists love to deceive people, and so therefore their subject pool is thinking, well, what is the psychologist doing with me? And so they try to circumvent and change the data, and they generally use undergraduates and give them credit. We never do that in my lab. We never deceive people. We pay people to show up because we're going to torture them, because that's what I do. And then we say you can do whatever you want to do. Your decisions are your decisions. All I want to do is measure your brain activity and see what you do. And you're anonymized. I'm going to give you a secret code for your data. So you can do what you want to do. No school credit, no weird coercion to do something. And so there's been a real push to not only debunk a lot of famous, so-called famous papers in psychology that just haven't been replicated, but also study people who are not what's called weirds. So a anthropologist at Harvard University has wrote some wonderful books, his name is Joe Henrichs, about the weirds. And weirds are Western, educated, industrial, rich, democratic societies. It turns out us, we're not normal when you look at the rest of the world. When you look at small-scale societies, when you look at societies that live in different hemispheres, I mean, personality types are different, behaviors are different. On some measures, brain activity is different. And so if we're just going to study undergraduates in American and European universities, we're going to have a very biased view of the world. So there's been a big push to study non-weirds. So in my lab, what we do is we generally start with some weirds. We call these convenient samples. Let me just do this study in the lab and see what mechanisms I'm finding. And then go back out in the world and say, okay, now for free-roaming humans, does this really work? And that's why I've been to so many countries and gone so many weird places, because I want to convince myself, because I'm a skeptic, because I don't trust science, that what I'm doing is not crap, right? And I don't want to go on TV or in the newspaper and go, we know for sure why. All I can say is, for the 80 people we studied, or the 500 people we studied, we found this result. So I think as scientists, we should be very humble about the sausage that we're making, and that sausage is never perfectly formed and spiced and delicious. It's always going to be a little bit off because we are constrained. So be skeptical, but be nice about it. How about that? Kristen, can we do some questions?
Absolutely.
Thank you.
I know. It's been a long day.
This is the hard part. She said she has all these
Good.
questions for me.
Thank you for being here. For those of you who have not been to one of our events and have not seen this before, you're welcome to pull out your phone, type that in. This is the app we have, Ask Your Questions. It's a little bit easier than passing a mic, and the beauty is you get to upvote questions. I don't know if you can downvote questions, but put your questions in. I am absolutely looking at them, and we're going to bring them into the conversation. We've got about 20, 25 minutes here. So please feel free to do that. I want to incorporate that. And yeah, I've had a long day. I'm going to stand up again out of the chair. I want to start a little bit with this idea of convergence, right, which you've talked a little bit about here. Convergence in science. We have a great tendency as society, outside the scientific institutions, to be like some studies show, right? We like to kind of look at some studies, whether it's trying to reinforce an argument we're trying to make, or because it sparked our interest, right? And what you're saying, which we know is critical, is that to look for convergence around scientific issues to start to believe the trustworthiness of that information coming out. And yet, we know our brains don't necessarily love to do that at times. From some of your work, how have you approached that from a more general sort of public advice audience about when we're looking at all of this data coming out, understanding truly convergence versus some studies, and the tension of our tendencies to want to look at some studies?
That's the key question. So I think there's two ways to think about that. One is that in sort of standard statistical analyses, the criterion for a significant result is a result that is less likely than 1 in 20 to be wrong. So there's nothing special about 1 in 20, but that's sort of where most findings or most statisticians kind of have settled on. So you can't have perfection. My study's not going to be perfect. There's always noise in data. There's always some uncertainty in what you're doing. So from a consumer perspective, that means every 1 out of 20 study is going to be wrong. It's going to be rando stuff, like my friends with a testosterone study in Switzerland. They didn't, well, they kind of cheated statistically, but they didn't fake the data. They just tortured the data until nature confessed. So think about anything you see in the news or read in a scientific journal. 1 out of 20 is going to be wrong. Now, what do you do with that? That's, I think, where it gets interesting. So I actually wrote a blog about this recently. I think one reason we don't want to critique things, first of all, you have to have a bit of a basis to really critique it well. So you heard me say 4 times already, it's not my field. I know the area where I have expertise. I know the areas where I don't. So again, let's be humble and say, hey, I don't know everything. I'm not an expert on longevity. I've read a bunch of papers. It's not my area. I have some understanding of that. But the second thing is, from a social perspective, it's actually difficult to be disagreeable. If I disagree with everything, then people will think I'm a disagreeable human being, and who wants to be around a disagreeable person? So hopefully, like me, you may have a subset of friends who enjoy you disagreeing with them, and you can have that kind, thoughtful debate, sometimes with an elevated volume. Occasionally, you get excited about things. And I think that's wonderful to have, 2 or 3 or 4 friends, maybe with a different background, and you can debate these things in a nice way, but be a little disagreeable. If they know you're not a disagreeable human being. And it's, I think, counter to our normal desire to get along and be seen as nice and all that. But when you see scientists who are cranky, that's one reason why, is we spend 99% of our time just being disagreeable humans, and we got to turn it off when we're around regular human beings.
I also think there's an element of debate and disagreement about what are we debating and disagreeing about, right? Are we debating and disagreeing about a convergence around scientific information or data or facts? Or are we debating or disagreeing about something else, right? A policy outcome, a value, a belief system, a decision we have to make. How have you thought about the intersection of trusting convergent science when it comes to needing to make a decision? Right? And I want to take this a little bit step further, follow my circuitous thought here, which is to get to really strong convergence or even that sort of consensus-based parts of science, there's a lot of emerging and unfolding fields that as a society we are trying to make decisions about, to do something or not do something. And so sometimes science doesn't allow us to do that because it's not there yet. So how do you rectify the value of looking at research and science in some of those situations and predicaments?
Again, a very hard question, which I agree.
Solve the world's
problems,
problems, please.
When I first did the work on trust, we worked on country level, and we show that trust is among the strongest predictors social scientists have found to understand why countries are rich or poor. And we characterize why countries are rich or poor based on their social structures, their government structures. And the World Bank flew me out, like, oh my gosh, we're going to implement this in these developing countries, and they'll grow faster, and people will have higher prosperity. And then, you go home and go, well, it was one research study. I mean, I think it was well done. No, they did implement some of these policies, but I think there's a giant, canyon between even a number of scientific studies and public policy that can affect millions of people. And we have lots of examples of failed policy that has, killed people, many times over. So I think the approach now is much more like software engineering. Who's the MIT software guy I was talking to? There he is. Hi. Jim? Mark, yeah. Mark's a computer scientist. Computer guy. He called himself a computer guy. I think in computer, when we write software, we use something called Agile, right? We sort of do, you write a small piece of software, throw it out there, see if it works, and then you just keep improving it. And I think we're seeing that in the policy world now, which is start small scale. This is, by the way, this is the Mythbusters ethos, right? Start small scale before you do something big. Maybe blow up something small before I blow up something big to make sure it all works. So I think if we start small scale with policy, then I think we're going to have more confidence that this scientific finding is applicable in the world in which people really live as opposed to a laboratory. And again, I think this is the reason to study non-weirds, to do field work. I think one of the beautiful things that the framers of the Constitution had in the US is this federal system. So we're running county level and state level experiments all the time, right? Colorado was the first state to legalize marijuana. That's an experiment we're running on ourselves. Very interesting, right? And then a bunch of other states decided to run this experiment as well. So, you know, is it good or bad to legalize marijuana? Not my area. You guys probably have more experience than that with me. I think it's both, right? There's some good and there's some bad. And the question is, should we spend all this money to enforce something that people have always done? So it's difficult. So I say small scale. Go small scale and get some confidence.
Okay. I'm going to turn to audience questions because I have a lot more, but there's a lot coming in already. I'm going to start here, which is kind of the basis and the foundation of some of your work and stuff, which is around oxytocin and testosterone. You know, some of it have thought of as an emotional hormone, but to think of trust as a more rational process. So could you elaborate between the two of those as being this neurochemical, emotional hormone and trust being more of a rational thinking?
Remember I said, Kristen, how people are going to be disagreeable? I'm going to disagree with everything you said.
Okay.
So
And why?
I'm uninterested in trust as a hormone, which is binding to breast and uterus and things I don't care about, all way too messy organs to work in my lab. I'm interested in oxytocin as a neurochemical, so I'm a brain guy. So no hormones for me. Yeah, so the question is, re-ask the question.
Yeah, so the idea of oxytocin, testosterone being different than trust as a more rational thinking process.
Yeah, so no hard, you know, you're in this sort of Cartesian world of this hard split between emotion and reason. There's no hard split, it's an integrated organ. So I don't even like the word mind. I just don't use that. You're a brain. You have an embodied brain. It's communicating to all kinds of other organs. It's working at about a millisecond frequency. It's integrated. The cognitive part of your brain is integrated with the emotional part. Emotions are how the brain identifies the value of an experience. So if this is an important decision I'm making that regards, say, trusting another person, there's going to be a cognitive aspect. I'm going to look at your body language. I'm going to think about, say, the contract we're going to sign. I'm going to get a gut feeling about it as well. And that gut feeling is driven by the oxytocin response. So this is an integrated system. So if I'm going to buy a company for $100 million, I'm going to do a lot of due diligence, and I'm going to have a high cognitive load to do that. At the same time, if you read stories of people who have, say, bought companies or made big decisions, oftentimes the two CEOs meet and they go, should we merge? Yeah, let's do it. Shake hands. The lawyers will work out the details. There's this sense that I want to work with this person, or like politicians, right? Like all these politicians in the old days were like, oh, I like that Putin guy. I can trust him. How many of our presidents said that? Like all of them, probably. Even Trump, I think, said that recently. Like, Putin's an awesome guy. So, you know, that gut instinct can lead us astray, but we still want to have the cognitive part as well. So it's an integrated system. Just like your heart or your liver's integrated. It has different parts, but they all talk to each other. Does that help you, or did I just confuse you?
I think it is, but let me have you elaborate a little bit more, because you've done some work, right, where you've given people oxytocin and had them play games and make decisions, right, economic decisions. Talk to me about some of those experiences. Give us some real-world examples of how that affected decision-making.
Yeah, so oxytocin is a reactive neurochemical. If I have a positive interaction with you, you hold the door for me and smile, or you show you trust me in some way, or you're nice to me, my brain releases oxytocin and causes me to reciprocate that. So in the work we've done on this, that was the early work. So you're nice to me, I'm nice to you. I think of oxytocin as the biological basis for the golden rule, and then testosterone is the anti-golden rule. You're bad to me, I'm going to try to murder you because I have high testosterone, let's say. Okay, and that's also useful because it means the threat of violence keeps people from behaving badly, sometimes. I'm not trying to make a pro-violence claim here, that sounded weird, but anyway, you know what I mean. The threat of punishment, let's say the threat of punishment keeps people sometimes on the straight and narrow. What we've done in the last 5 years is really look at much more ecologically valid settings in which we had people making decisions over, instead of $10 stakes, $1,000 stakes. We measured individuals who were working adults between 25 and 50, like free roaming humans, as I call them. We measured not just oxytocin, but a whole slew of neurologic responses from high frequency 256 lead EEGs to all kinds of measures on the peripheral nervous system. So tons of data. This is your tax money at work. And we found is that, why do we initiate trust in somebody? We have shared physiology. So when we're here together, we begin to synchronize our brains, our physiology synchronized. So if I'm well synchronized with you, it's gonna be easier to trust you. This is all unconscious, of course. And then if I show you I trust you or I'm nice to you in some way, then you tend to reciprocate with me. So who doesn't reciprocate? People under high stress. Stress inhibits the oxytocin response. People with high testosterone, teenage males in particular. And then the third is people who are psychopaths. So I've done a fair amount of work with criminal psychopaths. They tend to lack this cooperate with others sort of approach. It's about 2% of the population. So it's those two people in the back I pointed out before. Kidding. And they are poor social creatures. They don't engage with people very well. So again, the good news is, from a social perspective, 2% of the population psychopaths means you're not going to see them very often. If you see them, cut them loose. You can't fix them. They're not ever going to get better. They don't do well. The other people who are not behaving nicely are mostly people having a bad day. Right? That's about 5% of the population. They are losing their minds, stressed out. They're good people having a bad day, and tomorrow they're probably going to be a lot better. So, and then we're at whatever that is, 92% of the population are going to be just fine. That's pretty amazing, actually, if you think about it. Again, this is worldwide. We've done this everywhere we can, as you mentioned, Papua New Guinea, other places. So back to trust in science. Sorry, I'm doing a long answer, but it's such a good question. We're so biased towards trusting other people. And there's data to support this, right? You guys remember this game, Who Wants to Be a Millionaire? And you have those 3 lifelines, call your stupid friend or whatever. They've done actually research on which the best thing to do is always poll the audience. So if you have enough people, conversion evidence, saying, yeah, you should, it was Frank Sinatra who sang this song first, they're probably right, not your stupid friend, even if he or she went to MIT like Mark was teaching at.
Thanks. Why do you think there is so much distrust and animosity towards science right now? And then what could scientists and advocates do to foster trust?
That's a great question. Thanks for whoever asked that one. Yeah.
There's a lot of votes on
I'm a bit of an optimist, you guys, so bring me back to earth. I like skeptics. So by personality and by training, I'm very skeptical. So I like distrust. So we should all, we've learned, like the news, come on, right? Most of it's, again, trying to get eyeballs, right? The world's not going to hell in a handbasket. We're doing just fine as a species. It's all good, right? I think, staying out of the echo chamber of the media and social media probably is one of those things. Even if you look at, surveys of what Americans agree on, we agree on almost everything, right? There's some violence, there's some unhappiness, but look at all these people. Again, you guys most of you don't know each other. We're getting along just fine. And if we talked about policy issues, we'd probably agree on 9 out of 10 things, probably. 8 out of 10, who knows? So first of all, don't overblow. Yeah. By the way, I saw this thing that recently, I don't know where I saw it, so hopefully it's reasonable data, but something like 80% of the posts on X/Twitter are from like 10% of the people. It's not a town hall, it's people yelling, right? So yeah, don't take it. Number 1. Number 2, scientists are extraordinarily bad at communicating with the public, even though the public pays for a lot of their research through tax money. Extraordinarily bad. So there have been some pushes, and some scientific societies have given people media training. Like, how do I take a complicated scientific study and describe it so anyone can understand it? So recently my university asked me to teach a course on how to write your dissertation, because I've published so much, I've had so many students. And the first thing I tell them is, the title of your article, which is a seduction to read the article, to spend an hour of your life with me, declarative statement, no jargon. We did this thing, we found this thing. The abstract, no jargon, very clear, declarative statements. If you read most scientific journals, you can't even get through the abstract. You have no damn idea what they did. So because one of our criteria in science for impact is the number of citations, the number of other scholars who use your work and their work, I'm going to be a cite monkey. I want to just get everyone to read my paper, including the general public. So a lot of the things because I've worked on the neuroscience of storytelling as well, which is how you influence other people, I'm trying to tell a story in a scientific article, and we're just not trained to do it. And when I get on stage, I'm trying to tell a story as well.
There's a colleague in the audience here who does a lot with effective polarization and how we're actually much more closely aligned than we perceive as society. If you want to talk with him, his name's Martin Carcassonne. He'll be
Conversion evidence. I was right.
Alrighty. Okay, where do we go from here? We've got a few good things. I want to hit on this point which you had kind of started, which is you said don't trust science, right? But are you actually saying trust in the scientific method?
Bravo. Who said that? Raise your hand to me. Thank you, sir. Yeah, trust in the scientific method. The method means over time, we're going to wiggle around, make some mistakes, and we'll finally get to something that we have a lot of confidence in. Excuse me, I don't want to use the word trust, but I use high confidence. So the method is, the reason the method has persisted is because it's an effective way, let me use one bad word. Science is the most effective way to get rid of bullshit. Sorry, there's no other way to say it, right? The anomalous findings will disappear because we'll have so much evidence on this thing, and we'll have mechanistic evidence. Here's the mechanism, like aspirin causing a reduction in fevers. And then we have that mechanism, we can manipulate that mechanism and show the causal effects. Now I'm convinced. Up to, always a little bit of skepticism, but I'm convinced. Yeah, so the method, trust the method, not the finding.
Great. All right.
Said that.
Yeah, that's good. I'm learning people's names. This is a good sign. How do you think AI can or will influence trust in science?
Yeah, I was going to say that. So now when you submit a scientific article to a journal, you submit it for peer review, there's a box on most journals that said, did you use AI to write this paper? I haven't done that yet because the process of writing for me is a process of discovery. I find the errors in the argument. I find missing analysis, right? And it's super painful with graduate students because I have to go through 60, 70 versions of a scientific article before we submit it because I had to push them like, I'm not convinced. You haven't made this point clear enough. Give me more evidence, do more analysis, or this analysis is weak, right? Do more, do more, do more because I want to have that confidence before I submit it because I don't want to be that guy that has the paper either retracted or someone else finds the opposite result. By the way, which happens a lot, and that's a good thing for the scientific method, where someone submits something, top journal. So I have my students read, they don't know this, read bad papers on purpose and have them find the error. What's wrong with this? This is debunked. Can you find it? So, yeah, I think I've lost my train of thought.
AI.
AI, thank you. AI could be really useful. When I have students whose native language is not English, they will use AI, and you can kind of tell, because it gets this kind of that averagey, pablum-y language you have seen. From the policy perspective, I think AI might do a better version of how might I apply this to public policy than some weirdo in a laboratory who's never seen the sunshine. Maybe, right?
Great.
So I'm hopeful about AI, but I don't want to bet the farm.
I had heard this, and I don't know if I've shared this with some of you before. Where we are currently is like you treat AI like an intern, right? Maybe not a great intern at times too, right? And then you can use that application. It helps you stimulate your thinking, and then you come through and you vet it and you check it and you actually apply your own rational thinking and evidence and science into it. But this idea of stop thinking of AI in such a fearful way, right? But how can we think about integrating it into our work? And so I like thinking of it as an intern, is what I had heard someone else say.
Perfect. I
I'm
love
stealing
that.
it, but like, yeah.
Yeah, and there is also a field of science in which you don't begin with a hypothesis. This is very much in the AI kind of machine learning world, where you collect a bunch of data and just let it fall where it is. And by the way, the granting agencies, NIH and others, they hate this. I can't get them funded at all. But sometimes we do studies where we'll collect 25 different kinds of brain activity simultaneously, which is, by the way, really hard. My lab was one of the first to do this, like collect every piece of neurologic data while people are engaged in some kind of task. And then use AI kind of techniques, we call this machine learning, look at the relationship between these. So I mentioned this, Kristen, before we started here, but one of the dirty secrets in neuroscience is that there's no average. I mean, there's an average, but it's not a meaningful average. Everyone's brain's working differently. So God forbid, you have a stroke and you can't lift your right arm. I can tell you exactly where that stroke is in your brain. But why you like vanilla ice cream and I like chocolate, we have no damn idea. And that's interesting, right? We're all different on lots of dimensions, and that makes life really interesting, but it also makes generalizing difficult. So what we've tried to do with this a hypothesis, non-hypothesis driven research is say, what is the most important of these? All these things are happening in your brain. Which are the most important to understand this weird behavior people are doing? And that's a really different approach, which is very AI enabled. It depends on AI because there's so much data. I mean, like terabytes of data coming out of your brain. So, we've published research on this now. Is it useful? Kind of. I think people have not really embraced it as much, but it's a different way of doing science. You just throw everything in the kitchen sink at it, see what happens.
Alrighty, there's a lot of great questions here, you all. I like this one because it's a relational one. So someone said, as a scientist yourself, right? And there are some scientists here in the room, or others who value scientists, and they say, how do you help other scientists who get angry at people in society who don't trust science? And I'm going to use don't trust the scientific process, or probably the outcomes of convergent science. How can you help scientists? How do we help scientists each be a little bit more humble?
Gosh, that's such a great question, too. I'm humbled every day in my lab. Every day I realize how dumb I am. So my goal in life is to be slightly less stupid over time. And I don't always meet that goal every day, to be honest with you. I'm completely humbled all the time. And by the way, having a bunch of young, energetic, smart PhD students really is also humbling. They're doing stuff that's just like, I'm like, hey, let's try this thing. And they're like, we'll figure that out. I'm like, awesome. Bless you. I don't want to do it. Explain it to me. If it works, explain it to me later. So we do a lot of machine learning, which my students are doing, and I basically understand it, but I can't know how to do it. So I think there's two interesting issues there. I was going to say therapy and an SSRI probably is what they need. There is a sense of this, you see this in physicians as well, surgeons, this sort of like, I'm really good at this job, and therefore you can't question me. But I think, again, we all can be disagreeable, but be nice about it and be clear about what we know, what we don't know. So if you want to ask me about machine learning, I can tell you that much. If you want to tell me how to program it, I can't tell you how to do that. But I have graduate students who are pros at this, and they're amazing. And I will give them credit every day of my life because they punched all the buttons. I directed them on what to do, and then I poked them for weeks or months on how to make sure it really worked and why is it good. Explain it to me. If you can't explain it to me, you can't write it in an article, right? On and on and on. So I think science is very collaborative, and if you run a big lab, you do sometimes think you kind of own everything. But also knowing what you don't know is very important, right? So I did that a bunch of times. I was in Dr. Phil, 5 years ago, as an expert, not as a damaged person, on relationships. Yeah. By the way, Dr. Phil, a very nice guy. All those people get 3 months of a therapy that Dr. Phil pays for with, some, not him, some other therapy. So, they're people with real problems. This is a guy who cheated on his wife and they just had a baby and blah, 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 blah. Anyway, that's my area, relationships and connection. And some months later or years later, they emailed me, oh, we have this show on depression, and we want someone to talk about the neuroscience of depression, which I basically know, but I'm not an expert. And, I thought about it for about 60 seconds. It's fun to be on TV. I can give you names of like 3 people who spent their entire careers just studying the brain and depression who would be much better than me. So I think you've got to have this humility. We all work in teams. We're not experts. We're not little gods. And why be angry anyway? That's just weird to me. So, what a great question, though. I mean, you certainly see these people.
I appreciate that. I'm going to kind of take the moderator's prerogative and ask the final question. You all may be able to corner him and ask some of your other questions. But I do work at the Institute for Science and Policy. So a lot of our thinking is around systems and decision-making bodies and policies. And when a lot of your work and a lot of our conversation tonight when we're talking about trust is really interpersonal, right? It kind of comes down to the individual level and to this very human level. And yet we often are looking at how can we trust larger institutions, whether it's scientific institutions that come up with findings or whether it is regulatory agencies who need to kind of condense and coalesce information and put it out. I feel like there's some inherent tension of those institutions, just how you're framing the issue, that make them inherently a little bit untrustworthy if trust is truly this more individual, personal sort of thing. And yet we know there is extreme value in relying on some of these larger bodies to guide us, to help us make decisions, to put out information. How should we be rectifying this as a society? Should we be rethinking some of those institutions and systems? Should we be rethinking about communication and storytelling and spokespeople? How should we as a society, when we're seeing institutions really, really struggling at times when it comes to trust?
Yeah, it's a great question, and we've actually done a lot of research on this. So sort of 2 short answers. One is transparency. Let people decide for themselves before you make a decision as a policymaker. Really lay out the good and the bad and the ugly. I think sometimes, at least the policymakers I've worked with, they have a place they want to go, and they do the town halls and whatever, and they don't really listen to people. So I think we should listen to people. The second is we've actually done oxytocin administration studies and looked at trust in government and the president and the Supreme Court. And it turns out that oxytocin doesn't directly cause you to trust more of those institutions, but it causes you to trust people more. And if people trust that institution, you'll trust the institution. So we're back to convergence. Again, I think in this great social system that we have, where we have people who have their own opinions, which are diverse, and if we sort of add those up and go, well, most people think this is a good idea, we should probably enact a policy.
And surround ourselves with a diversity of thoughtful people.
Really important.
Right.
Absolutely. You don't want to be in the echo chamber.
Absolutely.
Diversity on as many dimensions as you can get. And there's really wonderful research that teams that are more diverse actually perform better. So pro-diversity, you guys.
Okay, I got one more question for you. Right, you're sitting with someone who you had a different opinion on and a different perspective. You do this a lot in your academic world, but outside of a more academic world, what are those elements you're looking for to have a really thoughtful conversation where you may be opening to changing your mind or having a different perspective or keeping an open mind about something? How do you personally approach that?
Yeah, I think I try to be a really good listener. So here's my tip for people that works for me. I call this listening with your eyes. Look at the person. They're talking to you. Don't look at your phone. Don't think about the next thing you're going to say. Shut the hell up and let them talk. And just let them go. Ask them some questions. First of all, if it's someone you like or someone you want to be around, what a privilege to have someone give you their full attention. Really be present for that and let that kind of percolate in. The second takeaway is we actually consolidate information during sleep. So if it's an important decision, if you're really trying to make something, a difficult decision, sleep on it. It really helps categorize information. So, hey, Susan told me this thing. It seems to be totally wrong, but she seems very confident in it. And I poked her a little bit. I was trying to be nice, a little disagreeable, like that crazy guy at the museum told me to do. But I slept on it, and then I started thinking about it. Kind of started making sense to me.
Great, thank you. All right, join me in thanking Paul Timmons. That was lovely. I really enjoyed doing this, talking to people, obviously. A couple thoughts for you all. Then there's some food and drink out there, and some of his books if you're interested. I definitely think this goes forward. I always want to take a moment, and I don't ever do it enough, to say thanks to a lot of people who really make the Institute possible, to make events like this possible. I'm just really grateful to both folks who are here in this room who are part of our Founders Circle, as well as our Allies Network. And so huge thanks to those people who keep championing our work. It is so critical in this day and age. So thank you very much to those people and those of you who are here tonight. I also want to thank my team, Trisha and Jordan and Max and Kate, who helped us bring this event together. I'm super grateful to work with really amazing, brilliant people every day. Our tech team, Ash, our catering and events team, the people behind the scenes that don't get to sit up here, who deserve so much of our thanks and praise and appreciation for the work that they do, who are out there tonight making sure we have a great event after tonight, selling his book and whatnot. So always a huge thanks to my colleagues. And thank you to you for being here tonight, for listening, hopefully coming with an open mind, learning, maybe meeting someone new. Really grateful for that. As I alluded to, we are kicking off a series. There's a great reflection in the window back there. Sorry, I have to turn around to see the slides. We're doing a little bit of a series. We're calling it a series. We've got two planned. We'll see kind of where we go from there. But you all kind of get the sneak preview for the Save the Date if you must be interested in that. And I don't know if you can see behind our heads, but September 10th, we've got our next event in this series where we're actually talking about the future of vaccines. And this is meant to be you had pointed out and brought up vaccines in your conversation. This is meant to be a very inclusive conversation of people who may be skeptical of vaccines and why. We have a great panel. We actually have a film screening as well, so it'll be a 24-minute documentary that got released this year that we're premiering from Neil Halloran, if you're familiar with him. He did a great data documentary on uncertainty in climate science. Brilliant, and he has this new one about some histories of vaccines, particularly smallpox. And so we're going to have that 24-minute documentary. Neil will be here and part of our panel, so we'll have the filmmaker here. And then we have a panel of other really thoughtful people who are working on immunology and working on vaccines. And it'll be a really great evening. September 10th, stay tuned. That will be in your inbox if you want to RSVP for that. And if you get a chance, let us know what you think about tonight. There's a QR code here. There's one out in the lobby. We really appreciate your feedback on our events, what you like, what you don't like, so we can make sure that we continue to serve your interest. Thank you so much. Please enjoy some food and drink out there and meet someone new. Thank you.